Hello everyone, my name is Bhavya and I am currently pursuing second year BTech in VVIT Nambur. Today I am going to discuss about the major application of arrays, that is searching techniques. Let us move further into the video to learn more interesting facts about searching techniques. So in this video I am going to explain about what is searching, types of searching techniques, and I'm majorly going to cover about linear and binary search with the help of algorithms and by taking appropriate examples and by solving them. I'm going to end up this video. So our first topic is what is searching. Searching means to find whether a particular element is present in an array or not. If the value is present in array, then we are going to say that the search is successful, and we are going to give that location of that value in that array. If the value is not present in the array, then we are going to display an appropriate message like we do not find that element, like searching is said to be unsuccessful. Basically, there are three types of searching techniques. One is linear, another is binary, and the third one is Fibonacci search. Here I have represented this searching techniques by using a flow chart. So here we have majorly three types of searching techniques: linear, binary, and Fibonacci. For linear search, we can use both sorted and unsorted types of arrays, but binary search we can only use sorted arrays, and same for Fibonacci series we can use only sorted arrays. Then let us move our discussion to the topic 3, that is linear search. So we are going to discuss about linear search. Discuss about linear search in detail. Linear search means simply traversing the array sequentially in order to find out the search item or search element. If the search element means if the search element is present in that particular array sequence, then we are going to return, then the linear search basically returns the location of that particular element of the array. If the desired element means that search element is not present there, then it's going to return null here. So as I have said that if search is successful, it returns the location, and if search is unsuccessful, then it says that the desired element is not found. And linear search is mostly used for unordered list. It also can be said like unsorted list, means the uh, arrays which are not in elements order, they're unordered, then we use this particular linear search in order to traverse this. So here we have in basic steps like algorithm, we can say it as algorithm, the algorithm for linear search. So first we need to read the search element from the user as an input. Then we need to compare the first element and the search element in the list. If the both are equal, then we are going to display like given element is found. Then we are going to terminate function after we found the element. If they both have not matched, then we are going to compare search element and next element in the list. If then we again if the both are equal, then we are going to print this and terminate the function. If they both are not equal, then we are going to repeat this step. The fourth step means then we are going to compare the search element and the next element. So we are going to repeat these steps until the last element of the list. If the last element of list doesn't also match, so we finally print that the element is not found in that particular array or function. So this is about linear. search. So here it is a basic example of linear search. So we have an array with a size of 9 and index value 0 to 8. So here we need to find an element 20, and you can see the array is unsorted. And now we are going to see that, so 20 is compared to 12 first, and they both are not equal, so it's going to be wrong. And then next it's compared to 5, and they both are not equal, it's not the element. Then they are compared to this, 20 is not equal to 10, and then 20 is not equal to 15, even 20 is not equal to 31, so 20 is equal to 20. Then this condition is going to be true, means the element we need to find is present at fifth index value. They are going to also return the index value. So finally they're going to return the index value of that particular element, and also display appropriate message like we found that particular element at a particular index. This is basically about the linear search. Now let us move to the binary search, which is the most important and the most used searching techniques. So let us discuss in detail about the binary search by using with the examples, algorithms, and the program about this binary search. So here, what is binary search? Binary search is a technique which works effectively on sorted lists. Hence, in order to search the element in some list, to binary search ensure that the list must be sorted. So if we need to find an element in a list by using binary search, we need to make sure that the particular list or array which we are going to give is in a sorted order. If it's not in a sorted order, then we need to sort it by using any of the six sorting techniques we have, as it's sorting is another application of array. We have that also, we can sort it. So binary search follows the method divide and conquer approach. It divides the list into two halves and compare it. If the middle element is found, if the middle element is equal to the search element, then we are going to display the message that element is found. And if not, then we are going to see that uh, and we are going to produce throughout the match, and we are going to divide these lists into sublists, and then we are going to apply again the binary search, means again dividing and conquering. Then we are going to finally find the element, means the search element in the array, and if not, then we are going to print that we didn't find the element. So let us see the algorithm of binary search. So first, as basic, we need to take input from the user. Then middle element is calculated. Here middle element is calculated by using taking average of low and high. Here low means the lowest index of the array, and high means highest index of the array. So by taking average, we can find the mid value, means middle element value. But then we need to compare the search element and the middle element in the sorted list. If they both are matched, we can say that given element is found and terminate the function. It's simple. If they both are not matched, as it normally not matches, search we need to check that search element is smaller or larger than the mid element. If the search element is smaller than the mid element, means search element is smaller than the mid element, then we are going to apply the same for the for the left sublist. And if the search element is larger than middle element, then we are going to apply the same 2 3 4 5 steps, means this step, this step, this step, and this step for right side sublist, means right sublist of the middle. Then repeat the same process uh, in the list or sublist until we get the required search element. If the element doesn't match, then we are going to print that the desired element is not in the function, and we are just going to terminate the function. So let us see an example in binary search that you could understand that what is the procedure to find an element by using binary search. Here we have an array from 0 to 9 index. So we have total 10 elements. Size of the array is 10 and we need to find 23. So by mid calculation means low plus high by 2 means 0 plus 9 by 2, which is going to be 4. So the mid element is at 4th index, so which is going to be 16. Of course 23 is not equal to 16. Then we are going to see that if uh, 16 is greater than or less than 23. Then as we can see that 16 less than 23, we are going to apply the same procedure for the left side, means we are going to move this thing to this side, means we are considering this as low and this as higher index of that particular sublist. So by calculating 5 plus 9 by 2, we are going to have a middle element of 7. Then we are going to compare that and it's going to be wrong, like they are both doesn't matches. Then we are going to check another time, then 23 less than 56 means it's smaller than 56. Then we are going to move towards this side. Then we have lower index as 5 and higher index as 6. So then we have a sublist named 23. Then we are going to match this and 23. So we finally find that particular element in that position of 5. So this is an example of that, and here is another example that you guys whoever watching this video can solve. This is also an index from 0 to 9 and it also contains the negative, means it's negative numbers and it's whole like integers, it's used by using integers. Then you can have a uh, more detail about that particular binary search if you solve this particular example. So let us move towards the program of binary search. So I have given I'm going to explain about the program of binary search. So here the libraries and main method we have defined. So we have taken the array with the 20 size 20 and we have declared these particular variables which we are going to use in the program. And in the first line we have asked for the array length, means the n number of, means how many elements we want to ln. Then then I have asked for input that what are the elements they want. So here I have written an code for sorting the given element in case if the given array is not sorted, then the binary search is not going to apply properly. So for that I have used this particular sorting technique. If you have any other methods to use, you can use, but I have used this particular sorting technique. So this is sorting technique which you can also refer. I just printed the sorted array up to here. Then I have just asked from the user that enter a value to find the particular, so what particular value we need to find in the array. So and I have just named it as key, and Then I have assigned, like, low means the lower index, and it's always going to be 0 at the initial state, and high means n minus 1. uh, and I have while low less than or equal to high, I am going to assign flag as 0, and I'm going to calculate the mid value. And as I've already shown in the algorithm, that if the mid value is after calculating mid value, first we are going to compare the mid value of the array to the key element, means the search element. So as you can see, we are going to compare it. If they both are equal, then we are going to assigning flag as 1 and just break, means terminate the function. If so if not, then we are going to check that search element is greater than the mid or less than the mid. So by using, we have the consecutive statements to make the low and higher indices different, means we are going to move either front of the mid or back of the mid. So by using that, we can calculate the mid values easily and make the sublist of the list. So after that, if flag is 1, flag would be 1 when the middle element is equal to the required search element. So if the required search element is equal to 1, then we are going to display that found element. Else, if we do not find that flag is 0, then we are going to simply display a not found. So here I have mentioned an output, like the particular program's output. So I have entered array length of 5, and this you can see. So for this type of mechanisms, I have applied the sorting technique. So here I have a sorted list, and then I have entered entered the value to be find, and it's just find it second indices value after sorting. So this is about the thing, and thank you for watching this video, guys. And the PPT which I have used in this particular YouTube video, and the notes of this particular video, and also the program of the binary search would be in the description. So please get downloaded if you have any queries. Thank you for watching this, guys. Signing off.